Okay, so today we're going to continue with our algebra review, and today we're going to continue solving system of equations, but today we're going to use the elimination method. So when you're solving using the elimination method, you need to get both equations into standard form. And what I mean by that is your equation should be having your x terms lined up and your y terms lined up. So it should be in the form of ax plus by equals c. This is standard form. If you need to change one or both equations so that when you combine the two equations, one variable will cancel out, then you can multiply by something to make that happen. Once you combine the two equations, one variable should cancel out. Once you get the value of that variable, you're going to solve for the remaining variable by plugging it back in to one of the original equations. Now, if both variables cancel out and the statement that is remaining is false, then it's no solution. If both variables cancel out and you're left with a true statement like 0 equals 0, then the answer is going to be all real numbers. Or sometimes you'll see it as infinitely many solutions. So let's try our examples. So here's our first problem. Notice they're both in standard form. So now, in order to do this, to get one of the variables to cancel out, I need to have the number in front of x or the number in front of y's, both y's, to be the same number but opposite signs. So for this one, I can either choose to eliminate x by multiplying my second equation by -2, or I could choose to eliminate y and multiply that second equation by +3. I'm going to try to eliminate x. And again, it's totally up to you. So my goal here is I'm going to try to eliminate x. And in order to do that, what I'm going to do is take my second equation and I'm going to multiply it by -2. I need to distribute -2 to the x, to the y, and to the 9. So then now I'm left with -2x plus 2y equals -18. I'm now going to take my first equation that I didn't do anything to, and I'm going to write it right underneath so that my x's are lined up, my y's are lined up, and so are my constants. I'm now going to combine the two equations or add them together. Notice my x term cancels out, and now I'm left with adding 2y plus 3y, which gives me 5y, and then -18 plus 13 gives me -5. I'm now going to divide both sides by +5, and I end up with y equals -1. I now take that newly found value of y, and then I'm going to plug it back in to one of the original equations. It doesn't matter which. It's totally up to you which one you plug it into. I always look for the one that has the least amount of work. So I'm going to take the second one. It looks like it has the least amount, not going to do a lot of multiplication. So I'm going to take my second equation. I'm now going to take what I found y equals, and I'm going to replace the y here with a -1. Be very careful when you have negative numbers. So I've got x and then the subtraction sign. Now I'm putting in the value of y, drop down the equal sign and the 9. I now can simplify that negative and make it x plus 1, and then subtract 1, and x equals 8. Now remember, be very neat when you're doing this so you remember which variable you've solved for first, because you're going to be writing your answers as ordered pairs. So you're going to put it in as x comma y. So it'll be 8 comma negative 1. Now remember, once you do this, you can plug it back in and see if it works. I highly recommend that you do the check if you've got the time. So the way that you're going to do the check is you're going to take both equations, 2x plus 3y equals 13. I'm going to plug in 8 and negative 1, so the 8 for the x, then negative 1 for the y, and then now I'm going to simplify. And if once I simplify that left side, if it does not give me 13, then I've done something wrong. So this one works. You have to check both if you're going to do the check. So let me write down the second equation. 8 minus negative 1 turns into 8 plus 1. 9 equals 9. This one also checks. So the answer that I found, the order pair, 8, negative 1, where these two lines intersect, the solution to this system is the correct answer. Now sometimes the system is going to be set up perfectly, where you're not going to need to multiply by anything to get a variable to cancel. Now, I could rearrange it and put the x first and then the y, but because this is already set up with the y's on top of each other, the x's and then the constants, I could go right into my solving process. I'm just going to add the two equations because when I add them together, the x's cancel out. And now I'm just left with adding 1y plus 1y, which gives me 2y, and then 10 plus 20, which is 30. Divide by 2, and y equals 15. Now I take this newly found value of y, and I need to plug it back in to one of the originals. I'm going to go ahead and plug it into the second one. The y plus x equals 20. Y is 15. So replace that. So I put that in place of the y. Rewrite everything else in the problem. Subtract the 15. And x is equal to 5. And again, when you write it in as an order pair, x goes first, y goes second. If you do not put it in the order pair in the right order, I will take off points. And again, you can do the check here to make sure it works. Again, I highly recommend the check because one little sign mistake and your answer could be wrong. It could look right, but it could be wrong by just a simple calculation error. Okay, so here's my next system. It's in standard form, but notice for this one, in order to get either x or y to eliminate, I'm going to need to multiply both equations because my goal here is to make the number in front of the variable to be basically the least common multiple between 3 and 2. Or if I wanted to eliminate y, I'd make it the least common multiple between 5 and 2. So if I want to make and eliminate x, I'm going to make them both 6s. If I want to eliminate y, I'm going to make them 10s. I'm going to go ahead and I'm going to eliminate x. So what I'm going to do in order to make that number in front of x, one of them to be a positive 6x and one to be a negative 6x, I need to multiply the first equation. I'm going to go ahead and multiply the first one by negative 2. So I'm going to take my first equation, because I'm going to eliminate x, and I'm going to distribute negative 2 to each one of the terms. And then for my second equation, I'm going to distribute a positive 3. And then that way, I'll end up with the same number but opposite signs in front of the x. If you want to eliminate y, you'd have to make them 10 and negative 10. So let's distribute. I get negative 6x, negative 4y, and negative 8. So that's what happened when I distributed negative 2 to the first equation. Now I'm going to distribute positive 3 to the bottom equation, and I'm going to write it right underneath so everything's lined up. So 3 times 2x is 6x, 3 times negative 5y is negative 15y, and then 3 times negative 29 is negative 87. Now it's set up beautifully, and my x's are going to cancel when I add the two equations. So once I add negative 6x plus 6x, that's gone. And now I can add negative 4y plus negative 15y and get negative 19y. And then negative 8 plus negative 87 gives me negative 95. Divide by negative 19. And I get y is equal to positive 5. I'm now going to take my newly found value of y and plug it back in to one of the beginning equations. I'll just go ahead and plug it into the first one. It's got some smaller numbers for me. So 3x plus 2y equals 4. I'm taking out y and replacing it with the 5. So rewrite everything except for the letter y, and then now put the 5. Follow order of operations by multiplying first. And now I begin my solving process by subtracting 10. 3x equals negative 6. Divide by positive 3. And x is equal to negative 2. So now I take my x and my y, and I write it as an ordered pair. Sometimes when you're trying to get a variable to eliminate, sometimes it's just a matter of multiplying by a negative 1 to make them cancel out. So just look to see what's going to be the best way to cancel one of the variables. Let's try the last official example, but I'm going to add 2 more examples for you. All right, so for this one, notice everything's lined up. They're both in standard form, but notice my y's are already set up to cancel. So I don't need to multiply anything here. All I'm going to do is add the 2 equations together. 1x plus 6x is 7x. My y's are going to cancel. And then I'm going to add 21 plus 21, and I get 42. Divide by 7, and x is equal to 6. Now, if you notice, most of the other examples that I had done, I solved for y first. So this is why it's important that you're writing clearly and you're remembering what variable you solved for first. Now I take my newly found value of x and plug it back in to one of the beginning examples or problems. So I'm going to take the first one, x minus 5y. You could have done the second one. It really doesn't matter. So again, I'm taking out the x this time and replacing it with 6. So 6 minus 5y equals 21. Subtract the 6. Negative 5y equals 15. Divide by negative 5. And y equals negative 3. Again, you're writing it as an ordered pair. So 6 comma negative 3. Now, if you notice when I did all these examples, none of them gave me no solution or all real numbers. So let me give you an example of what you may see in order to get a no solution or an all real numbers. These were always all one solution. meaning they only intersected, when they intersected, it was 1 point. Let's try the no solution where the lines would have been parallel. So I'm just going to make up some numbers here. So let's say I have 4x plus 5y equals 21. And then I gave you negative 4x minus 5y equals 5. Now, it's not always going to be this pretty where it's going to cancel out automatically for you. More than likely, you're going to have to multiply it by something to get it to cancel. But notice already, my x's cancel, my y's cancel, and when these are canceling, what's left behind is 0. And then 0 equals 26. Will this ever happen? Is this true or false? False. So when you're left with a false statement and both variables cancel out, that this will never happen, this is your no solution scenario. Let me add another one. All right, let's just say it was 4x plus 5y equals 20. And then negative 4x minus 5y equals negative 20. Notice, cancel, cancel, cancel. So 0 equals 0. This is true. So this would be all real numbers, or infinitely many. So when the variables cancel out and you're left with a true statement, then it's all real numbers. So be able to recognize these scenarios.